All right, here's an example where you have some part running in circles and another part going straight. So let's think about what this does. And I should state the question first. So my question is, find the equation of the tangent at t equals to pi over 4. All right, so what is this about? First, if you ignore the x and y, if you see 7t, this is about the z-coordinate. Z-coordinate, so if you take x and y to be this, and you take z to be going the upwards, then at t equal to 0, you're at 0 level. T equal to 1, you're at 7. T equals to 2, you're at 14. So you go from 0, 7, 14, 21, and just going up and up as t increases, right? On the other hand, if you just look at the x and y, let's first ignore the 4 for a moment. You have cosine of an angle times sine of an angle. What's that? So if you had cosine theta comma sine theta, where is this on?
Circle.
It's on the unit circle, right? Now if you put 4 in front, what happens? It's bigger. It will be on a circle of radius 4. Okay. And then this theta, because this theta is 3t, that means it's going around counterclockwise as t increases, right? And then if you think about the role of this 3, if this is bigger, the theta will change faster. That means you're going to go around faster, right? Yes?
How do you know it's going counterclockwise?
I mean, see, cosine theta comma sine theta. It's a circle with angle theta from the positive x-axis, right?
Yeah, I got you.
So if theta increases, then you're going this way, which is counterclockwise. Okay. So this number 3, if that's bigger, say 10, that will make the theta increase even faster, right? If this is smaller, say like 0.5, will be increasing slower, right? So this number here has to do with how fast the angle is changing, and later on you'll learn that that's actually what we call the angular speed. Angular speed is 3. So this 4 gives you the radius of the circle, and this is the angular speed. So if you only look at that x and y, you're going in circles. Okay? But at the same time, the z-coordinate is increasing, so it's going in circles, but increasing like that. Okay? And therefore, this type of functions have a name. It's called a helix. Helix is doing just that. Of course, you can think about helix that's rotating around the x-axis, or the y-axis, or going backwards. If you put minus here, instead of going up, it will be going down as a helix. So you can think about the helix in various directions. Okay. All right. And the question is trying to figure out the equation of the tangent line when t is equals to pi over 4. Let's try to solve this solution. What is the position of the particle at time t equals to pi over 4? That's 4 times cosine 3 pi over 4, 4 times sine 3 pi over 4, and 7 times pi over 4. draw the cosine graph. 2 pi, pi over 2, 3 pi over 2. Cosine graph goes like that. It's cosine. And 3 pi over 4 is 3/4 of the pi. So if this is pi, 3/4 is right here. Right? Now, what's this value then? We know that it's negative. Right? And pi over 4 family gives you radical 2 over 2. So we know that this value would be 4 times negative radical 2 over 2. Whereas for the sine, for the same angle, pi over 2, 3 pi over 2, this is a sine graph, and 3/4 is this spot. It's positive, so it's 4 times positive radical 2 over 2, and this is 7 pi over 4. 4 and 2 reduces, so we get negative 2 rad 2, comma 2 rad 2, comma 7 pi over 4. Okay. And then r prime of pi over 4, we need the derivative because we need to know the direction. To get the tangent line, we need the direction and the point, right? So let's differentiate, which gives you negative 12 sine 3t, 12 cosine 3t, and 7. And we're trying to plug in pi over 4 into t. Okay. We plug in the value. And then evaluate. Sine is positive, so you're going to get 6 radical 2. This is negative. So that's the direction. And now putting the direction and the point together, we end up with x, y, z. Direction vectors come first. Negative 6 radical 2, negative 6 radical 2. 7, t, 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 plus, 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 and we put the position vector, which is negative 2 radical 2, 2 radical 2, and 7 pi over 4. That's the equation of the line. Now, sometimes you might be asked for the normal plane. What's a normal plane? If you have some kind of a curve, at a given point, you can think about the tangent line, but another plane which is normal to the tangent line. Okay? In that case, that's called the normal plane. Okay? If that's asked, it's still using the same values. Okay? This will be your A, B, C, and x naught, y naught, z naught for the plane equation. I'll show you an example like that another time. Okay? Do you have any questions?